All right, second video is just going to focus on U substitution. So it's a different way to factor special types of polynomials. So if you notice, with each of these ones, you have three terms. So this is going to always be working, it doesn't always work, but it only works if you have a trinomial here with three terms. And so basically, usually trinomials would be like quadratics. So what we're going to try and do is transform this into a quadratic, even though it's quartic, right? And so what we can do is this thing called U substitution. We are going to replace our x squareds with u, right? So I'm going to say, all right, well, what if we make u, the letter u, equal to x squared, right? And in which case, now we're going to rewrite it, but in terms of u's. So x to the fourth would be u squared, because it's like x squared squared, right? 5x squared would be minus 5u, and then plus 6 would remain plus 6. And so at this point, we can just factor this with the u's, right? Thinking of things that multiply to positive 6 and add to negative 5, right? So we're going to have u here and a u here to multiply to u squared. And then we're going to have minus 3 on one of them and minus 2 on the other one. And then at this point, we are now going to go ahead and replace the u with what u was intended to equal, which would be x squared. So we have x squared minus 3 and x squared minus 2. And then at this point, neither of these are factorable, right? Neither of these are perfect squares or differences of squares. So we're done. This is as far as you could factor it. If it says equals 0, you would set them both equal to 0. You get 4 answers, plus and minus root 3 and plus and minus root 2. But in terms of factoring it, you would be done. So go ahead, you guys can pause the video, try this second one on your own, and then resume the video when you think you got it. All right, so with this one, it's x to the 6th and x to the 3rd. So we're going to say u is equal to x cubed. And that way we can write it as a quadratic. So this is going to be 2u squared minus 5u, and then minus 12. And then there's no GCFs. I should say that you're always looking for GCFs first, guys. In this case, I don't have one. And so we're going to have to try and factor this with a 2u here and a u there. And just thinking logically here, I know these need to multiply to negative 12. So I think if I tried, let's see here, if I did minus 6, nope, that's not going to work. If I did minus 4, right, that would get me to negative 8. If I tried minus 4 here, right, that would be negative 8u, and negative 4 would go with positive 3 to multiply to negative 12. And that would be great. And so again, just don't forget to replace your u's with your x squareds in this case. So this is going to be, actually, sorry, x to the 3rd in this case. So this is 2x to the 3rd plus 3. And this one would be x to the 3rd minus 4. This is an interesting one here. This one's definitely prime. This one, you're like, well, if this was x squared minus 4, you could factor in the x plus 2x minus 2, which would be conjugates. And then, it's just that this one's x cubed. So you'd be once you see cubed, you're looking for a difference of cubes like we did in the last video. But 4 is not a perfect cube. So you are done. It's actually as far as you could factor this one as well. So quick deductive reasoning, name 3 things about the polynomial for it to be factored with U substitution. You can write those down. But basically, it needs to be 3 terms. And then this first term needs to have like a twice as high a degree as the next term, right? 6, 3 or 4, 2. That's kind of the only way it works. And then that's pretty much it. So 3 terms, 2 is higher than the other. I know it says 3 things, but I guess the third thing would just be that it has to be actually factorable like a quadratic would have been after you did the u's. So that's it. That's the end of this video.